So what are we doing with this iPad here? This iPad is recording me and the board. You guys are not getting recorded. And after the class, I upload the video of the class on YouTube. Not for me to become a YouTuber, it's only for my kids, that is you all. To use this content for revising it. Switch it, move a little bit this side. Okay. So it is primarily for you guys to revise, okay? So that during the class you don't have to worry about taking notes, because sometimes you might find me speaking fast or slow. You don't have to worry about or take the stress for noting it down. Focus on understanding the concepts or following things that we do, and then if there is a doubt, feel free to ask me questions. I have special affinity for kids. I have 2 daughters myself. My elder one is in college now. So you guys are my future kids. Okay? So feel comfortable, ask questions. Okay? That's the thing. Hi. Okay. So I see Venuji. I see. Bhavish has also joined, right? Okay. Hey Manas. Everybody keep your video on so that when we talk, it makes sense to all of you, and if there is a doubt, I can read your eyes to make sure that I get that concern or question right in the first place. Alright? So, any questions, anything that is bothering? Okay, I forgot to ask you, Namita.
Aishani.
Say it one more time.
Aishani.
Aishani. That's an interesting name. It might take me some time to remember it.
Aishu is fine.
Aishu is fine. So if I pronounce your name incorrectly, bear with me. I'm getting old. Okay. I take few classes to get used to it. All right. So now we had a class last week where we talked about, what did we talk about, Switcha? Do you remember?
I think we talked about the rules of exponents, right?
Rules of exponents. Manas, are you clear with respect to what we learned in the last class? Oh, you had problem with your connectivity. So there could be some open questions. Now, Sidhu, are you clear about what do we mean by rule of exponents? Hi, Nanta. Do you know what is exponent, Sidhu?
Yeah.
Yeah? What are the rules of exponents? Are you clear about it?
I don't know that yet.
You don't know that yet. How about Bhavish?
I probably did learn, I probably forgot.
Okay. Anahita, do you remember what we did in the last class? Okay. How about Aishu? Aishu, did I say it right? Aishu? Yeah. Okay. So how about you, Ida? How comfortable are you about the concepts relating to exponents and the rules of exponents?
Is the number over the, let's say like, let's say 10 and then 5 over it?
Mm-hmm.
Yeah. Yeah, I'm pretty good at this.
Okay. How about you? Yeah. You're very clear. Now, one thing is, when we do the class, right? Like I said, I record the video of the class, send it to you guys after the class, and then every week I'm sending assignments. One thing I want everybody in the class to practice hereafter is make sure that I get the assignment back from you guys. Meaning, when I'm sending the assignment, you do the assignment. The expectation is you will show the assignment to your parents. So explaining, okay, this was the question, this is how I'm doing it. So when you give that narration back to your parents would know whether you have understood or not. And when you are explaining the things to your parents, you also would know whether you are able to articulate that well or not. Okay? That's the idea. I'm not trying to put anybody on the spot. The idea is your parents should feel confident, you should feel confident, and if you are not confident, that will come back to me as a feedback, say, okay, fine, my child has not understood it, can you do it one more time? So it's an iterative process where we learn things, we forget things as a human being, and we keep going back to the concepts, learn it, and make sure that we are very, very, very clear about it. Does it sound okay, reasonable to everybody? So I would assume that everybody will send me an assignment. So Swetcha, I have not seen an assignment. Did you do it?
I'm gonna turn it in this weekend.
Okay. Yeah. So try to follow the same week, because I will lose track of it. you finish it. I mean, I don't give a lot of assignments. You should be able to finish the assignment in 30 to 40 minutes. That's the level of assignment I give. Okay, it's not to get you guys stressed out, but to make sure that you're able to apply the concept that we have learned. Okay. Yes, Anaita, you're asking questions. Where is your assignment?
I was doing the homework today.
Okay. So what I'm saying is, in a week's time, try to do planning in such a way that you're able to turn it around before the next class, before the next week's class, basically. Yeah. All right. All blabbering is over. Let's focus on the concepts. So, Kian, can you explain this class? What are the 3 rules of exponents that we have talked about in the class?
So we basically learned like how to simplify exponents, like if it's like 5 over 3 over like I don't know, 2 or something, it's 5 times 5 times 5, and then 10 times 10, and then we just like simplify it, like expand it out. And then we also have the kind of prime factorization, and then making like exponents and a multiplication problem with that, and yeah.
Okay. Fine. So I'll make sure that in next 6 months you all become good storytellers. Whatever you know, you should be able to articulate that. Okay. Now, when I talk about 3 rules of exponents, I'm essentially talking about, and again, it could be a repetition for some of you who have learned it before, and it might be an eye-opener for some of you who are coming across this for the first time. If I have this, it becomes x to the power a plus b. This is the first rule of exponents, where you are multiplying 2 exponents with the same base and the power gets added. And I'll decode that.
I can't see what you've written down.
I'm sorry, beta?
I can't see what you've written down.
But are you able to see the board? Maybe I have to change the font. Yeah?
I can barely see it.
Okay. Okay, let me use the center of the board and tell me if you are able to see it now. This is my first rule of exponent, which says x to the power a times x to the power b equals x to the power a plus b. Is it legible now?
I can see it.
Yeah, okay. Yaganya, can you hear me and see me okay? I mean, not me, the board rather. Yeah? Okay. So, this is the first rule of exponent. And what sense it makes to y'all? Aishu, how about you, beta? What is that I'm trying to do here?
Would you like multiply the you would add a plus b and then multiply the x's and then it would become ax.
Okay, so this is a generic rule. Let me break it down one more time. And kids who have learned this before, just bear with me. What this means, these are generic rules where I can plug in any value for x, 1, 2, 3, 4, 5, 6, 7, 8, 1 million, 1 billion, 1 trillion, whatever you want. And then some value for a and b. Okay? So now look at this. If I am saying 5 to the power 3 into 5 to the power 4. As per this, it says, these are 2 exponents which have same base 5 and the other powers 3 and 4. So this rule says if you have 2 exponents with the same base and different power, it will be equivalent to another exponent with the power being added. It will become 5 to the power 3 plus 4, which will be 7.
So 5 to the power of 7.
Yeah.
Yeah.
And there's a way to decode it. Bhavish, are you with me so far? So I will probably spend 15 minutes to decode all the 3 rules in the simplest possible way. And Kian, if I make you sleepy, let me know. Okay? So here, if I have any number to the power something, it simply means it's a way to represent a scenario. Let me use simpler numbers. This means 3 into 3 into 3 into 3. Okay? It might turn out to be 9, 3, 27, 81, whatever. But this is just a different representation, which we call as exponent, which has one thing as a base and this is a power. So this is a form of representation which is called the exponent form. If you don't want to learn this, you will say this is equal to this. So this is just a short form. Let's say tomorrow if you have to multiply, let's say 7 with itself, 100 times and you don't want to waste so much of ink, you can put that in like this. Yeah, this is exponent. Simple definition. Bhavish, Sidhu, am I making sense so far? Yeah?
So this is the second rule?
No, we are still on the first rule. So there are 3 rules. We'll decode all of them one by one. Okay? So this is the first. I've still not talked about the rule. I'm just going with the basic definition of what is understanding of an exponent. Okay? So this is the exponent. Now, this exponent is a form to represent repeated multiplication of the same number. If I can give a description to it. Yeah? Switch off with me so far? Okay. Now, what I'm trying to do is, let's say if I want to multiply 2 to the power 4 with 2 to the power 3. And my biggest problem in life is my intelligence level, which is very low. Okay? So, what I will do is, I just know what does this mean. 2 to the power 4 is nothing but, let me write it just below this. 2 to the power 4 is 2 into 2 into 2 into 2. I have just interpreted this in the way we understand. Okay? Bhavish, Yaganya, you guys have turned off your video. I'm not sure if you guys are with me or not. Keep your video on. Now, this is 2 to the power 4 is 2 into 2 into 2 into 2. Same way, 2 to the power 3 is nothing but 2 into 2 into 2. So, I have done nothing so far. I just split this into simplified way that I understand. I split this into simplified way that I understand. So, this thing which was looking cryptic to us, now we know what exactly it means. Yeah? Now, what I will do is, okay, how many 2's I see? 1, 2, 3, 4, 5, 6, 7. If I want to write it back in the same exponent form, what will that be? 2 to the power?
7.
I want the new bits. 2 to the power 7?
Yeah, 7.
Sidhu and Bhavish, do you guys agree? 2 to the power 7? That's what it looks like?
Yeah.
It's simple counting, right? I mean, your teacher can manage with his level of intelligence for now. Okay? So, but there's something that we are interpreting out of it. What you are seeing is you had one exponent and this another exponent that you were trying to multiply. And what happened was both had the same base and different powers. So, it translated into a third exponent with the same base and the power got added. Yeah? So, if you don't want to trust your teacher with just one example, right? I mean, there's a problem, right? And math is a subject that you have to keep on doubting, keep on trying yourself. Don't go by what somebody says. Yes, Peter.
Is the answer 2 to the power of 7, or if you want to completely simplify?
Why you want to waste your time finding it out? That's an easy task, right?
Yeah.
I'm not trying to make you guys calculators. Calculators comes for a very cheap price. The concept is what we'll focus on.
So
Yeah?
is that the answer?
That will be the answer. I mean, based on my experience so
Unless the
far.
question asks you to simplify it.
Unless they ask you to simplify it. And we'll look at the simplification part also again. Manas, are you with me? Are you able to hear me okay this time? Okay. Sidhu, Bhavish, Jaganya, Anahita, everybody okay? Nobody is feeling sleepy right now. Yeah? Nobody? Okay, cool. Now, the teacher just picked one number, did something, and he's forcing you guys to believe it. No, let's check it one more time. Let's see if I do 5 to the power 2 into 5 to the power 3. Same thing. 5 to the power 2 is 5 into 5, and 5 to the power 3 is 5 into 5 into 5. How many 5 do you see? 5. That translates into 5 to the power 1, 2, 3, 4, 5. Now it is getting more serious, correct? Basically, when you are multiplying two exponents with the same base, you end up adding the power.
You don't multiply the 5 times 5. Just keep it.
You keep them same, right? I mean, for you, these are two numbers. If I call this guy apple and this guy is orange, these are two different fruits. But they have one characteristic, that is their bases are the same. And that is where the power gets added. So now we certainly don't want to waste a lot of time and energy on this one. What we are saying is, based on the experience, based on the examples we took, we are deriving our first conclusion. and this will hold true for any number that you want to play with. X to the power a times x to the power b equals x to the power a plus b. Bhavish, are you able to see the corner of the board or no?
Yeah, I can see it.
Okay, cool. So here, this became a rule for us. This is the first rule of exponent. When you multiply two exponents with the same base, the resulting exponent will have the power added. Yep, make sense? And there's one more thing. Again, this is an open secret. I keep disclosing my age to all the kids in my class. I'm 49. I'm going to turn 50 next year. Okay. And why I'm saying this is because when I'm doing math, I'm not doing it as a stressful exercise. I kind of enjoy it. I want you guys to enjoy it too. Now, for enjoying it, you have to learn playing. So let's see, how do I play? I'll just show you guys one example. I call it tic-tac-toe. Okay. If somebody says multiply 5 by 9 into 3 by 6 into 5 by 25 into 8 by 17 or 14, let's say. What will you do under the normal circumstances? You'll multiply this and this, and multiply this and this, and then divide this whole thing by this. Right? Whatever you get. I would not do that. I would want you to play. So this is what I will do. This becomes 5 into 3 into 5 into 8. Everything on the second floor goes together. And then everything that I have on the first floor or the denominator stays together. Okay? Now what I will do is I will factorize them into smaller numbers.
What's the last number?
What is that, Ruka?
The last fraction.
8 over 14. So again, this is not about you guys doing it. I'm showing you guys a chance to find out an opportunity to play. Okay. So here, whatever I have here, this is my final thing. I'm still not wanting to multiply them all and get stressed out. Because I only know tables in 20. Beyond that is a big problem. So here, whatever I have, what I will do is I'll start factorizing them. 5 is a prime number, I can leave 5 as 5. 3 is also a prime number, I'll leave 3 as a 3. 5 is another prime number, I'll leave it like that. 8 I can break into 4 into 2. Okay? If you want to further break it, this 4 also you can break into 2 into 2. Okay? So all the thing we had in the numerator, we have split that into smaller pieces. 9 I can break into 3 into 3. 6 I can break into 2 into 3. 25 I can break into 5 into 5. And 14 I can break into 2 into 7. So far, nothing stressful, right? I'm just factorizing the bigger number into prime factors or the smallest number that we can think of. Now the time has come to play. This 3 and this 3 I will do tic-tac-toe. This 5 and this 5 I can do tic-tac-toe. So one number above, one number below, you can do tic-tac-toe and you can knock it off. This 5 and this 5 I'll do tic-tac-toe. This 2 and this 2 I'll do tic-tac-toe. I have another 2 tic-tac-toe. I think that's it. What I have now is 2 in the numerator and 3 into 3 into 7. 3 3 is 9, 7 is 63. Isn't this looking cute now? Much cuter than the monster that we were dealing with.
Is that the answer?
I'm sorry?
Is that the answer?
This is where it is. This is 2 over 63. This is what we got. Now you can convert them to decimal. Yeah?
Did you get the same answer if you did all the multiplication?
Of course, yeah. Yeah. So this is a method to simplify the things.
Oh.
Yeah. So we had too many fractions to multiply. We didn't want to take the stress of multiplying big numbers and then dividing by another big number. So this works best in case of multiplication and division only. We will not do that in the case of addition subtraction. Manas, is that sounding okay? Yeah.
Yeah.
Sidhu and Bhavish, okay?
Yeah.
It's an opportunity to play. Anahita and Yaganya have heard me do this fun activity quite a number of times. So for them it's not new, but it just re-emphasizes that we have to always look at opportunity to simplify the calculation we do. Okay, because if I keep on multiplying these numbers, then my chance of making mistake is more. If I'm dealing with smaller numbers, I'm better off. Make sense? Okay. So the next thing here is, so again, I did this in between when I was talking about exponents, because this will come back to this one. Okay? Now, this was just a, like you when you are watching a movie, you watch ads in between, right? This was the ad in between the class. Did the ad make you guys sleep? No? Okay. Alright. So coming back to the next rule. Now let's talk about it. If I say 8 to the power 7 divided by 8 to the power 4. This is my second rule of exponent. And forget about the rule. It's a fun activity that we're going to do. 8 to the power 7 by 8 to the power 4. I can write this as 8 to the power 7 divided by 8 to the power 4. Correct? So far okay? Nothing intelligent here? Now 8 to the power 7. Let's break it down. Always look for ways to simplify things, okay? Don't overwhelm yourself by thinking too much or overthinking. Are you sure okay with that so far?
Yeah.
Not making you guys sleepy or tired, right? Okay. 8 to the power 7 is what? 7 times 8. Yeah? What does this mean? 4 times 8. I'm saying 4 times 8, but that should not be misunderstood by 4 times 8, right? 8, 8, 8, 8, 8, 4 times. Now we have another opportunity to play. 1, 8, 1, 8, tic-tac-toe. 1, 8, 1, 8, tic-tac-toe. This 8, tic-tac-toe. What we are left with? 1, 2, 3, 4, 8s. Which could be 8 to the power 4.
There's one more for this. Should that be crossed out too on the bottom?
That means you are not sleepy. It was me who was tweaking. Okay, so no, you're right now. Good that you observed that. Okay, so what we are left with? 1, 2, 3, 8. I mean, I would have found that out when I was about to put the answer. Then I would have realized, oh something is missing. But that good that you caught it. We are left with 1, 2, 3, 8s, which is as good as 8 to the power 3. Now you look at it. What happened here? You had two exponents with the same base. Power of the denominator got subtracted from the power of the numerator. 7 minus 4. Yeah? Bhavesh, Sidhu, am I making little bit of sense so far? Little bit?
Yeah, you are.
Manas, a little?
Yeah.
Okay, cool. But one example is never enough. Math is based on a lot of experiments, lot of practice, lot of data collection, then interpretations are drawn out of it. Let's not believe this one problem to make a rule for rest of our life. Let's look at one more thing. Okay, how about 13 to the power 8? Not 8 this time. Let's say 5 divided by 13 to the power 2. Simple, same thing. 13 into 13 into 13 into 13 into 13 divided by here 13 into 13 2 times. Time for playing. Tic-tac-toe, tic-tac-toe. 1, 2, 3. 13 to the power 3. Same thing. We had two exponents with the same base, different power. The power of the denominator got subtracted from the power of the numerator. Yeah? That is how 5 minus 2 gave you a 3. Now we can believe it. So this becomes our second rule of exponent. We'll generalize this and say any number to the power a divided by same number to the power b equals same number to the power a minus b. This is the second rule of exponent. Is it same as what I told you in the last class? Am I changing my plan? No, right? Yeah, okay. You guys are okay. So this is the second rule of exponent. Now these two are worthy to be trusted, right? And so far we will not have any question, concern, doubt. Minus, you agree? Okay.
Yeah.
Sidhu, fine so far? Okay, now let's move on to the next one. If I say 4 to the power 3 in parentheses to the power 2.
Wait, this the second rule or the third rule?
I'm sorry, Luca?
Is this the second rule?
This was the first rule when you were multiplying two exponents with the same base, your power got added. This was the second rule when you were dividing one exponent with another exponent, both have same base. The power of the denominator got subtracted from the power of numerator. Now we are looking at the third rule. But I have not disclosed yet what the rule is. Yeah? Is that okay?
Yeah.
Now, I am saying 4 to the power 3 to the power 2. What am I trying to do now?
I think it's like 4 to the power of 3 first, and then you add that number to the power of 2.
So again, as I said, in 6 months' time, I'll make sure that you guys become a good storyteller. Now, what you said might be correct, but I will do that like a 5-year-old baby. Will a 5-year-old baby deal with exponent?
No.
Okay, what I meant by that was, we'll go slow. If I have something in the parentheses and then a square, what I'm saying is, if I put like this, what I'm saying is x into x. Whatever I have inside the parentheses is square of that, correct? So here, in this case, it will become, whatever I have inside the parentheses, which is 4 to the power 3, is square of that, meaning same thing again. Yeah? No?
Oh, yeah.
Yeah? If I say 3 to the power 4 to the power 3, what I'm saying is 3 to the power 4 into 3 to the power 4 into 3 to the power 4. Correct? Whatever I have inside the parentheses,
Oh,
cube of that.
yeah.
So let me not confuse you guys with two problems at the same time. So if you are looking at this, so you have 4 to the power 3 in parentheses to the power 2. That means this whole thing is repeated twice. Now, relate this with this guy. Something to the power A times something to the power B becomes something to the power A plus B.
6.
Something to the power 6. Which is as good as 3 times 2. And don't trust me again. Let's make it 3. What will happen? I will add another 4 to the power 3. And then I'll have 3 plus 3 plus 3, 9. Yeah?
4 to the power 9.
So that is, what is happening is, whatever I have inside the parentheses, that power is getting multiplied with the power outside the parentheses. And that will be our third rule of exponent, which says, Siddhu and Bhavish, Yaganya, Anahita and Manas. Are you guys with me or I lost you guys?
I'm with you. I'm alright.
Okay, wonderful. So my third rule of exponent says x to the power a in parentheses to the power b equals x to the power a times b. Yeah?
Wait, so can you like explain it in like your actual like words instead of the terms of math?
I'm sorry, Luca?
How would you say it?
One more time.
Can you like explain it in words not in math terms?
Okay, so look at this.
Like rule 3.
Let's look at it, okay? 2 to the power 3, okay? In parentheses to the power 4. That becomes 2 to the power 3 into 2 to the power 3 into 2 to the power 3 into 2 to the power 3. 4 times because I have a power of 4 here. Yeah?
So it's like a double exponent.
Not double exponent, I mean exponent to the power. I mean exponent and then you have another power to it. Yeah. What is happening here is, look at this rule. When you have two exponents with different powers, I mean some power, same power, different power, doesn't matter. When you're multiplying them, the power gets added. 3 plus 3 is 6. And then same thing here. This also becomes 3 plus 3 is 6. And now you have new exponent, same base but different power. this also gets added because this is now these two rules that we have looked at, these are written in stone. They will not change for the rest of our lives. Yeah? Okay? Not okay? You guys are lacking a little bit of energy. Don't get excited. Yeah, no, I mean, is it making sense better? Okay. See, your excitement or your happiness will be a function of how much you are appreciating what we are doing right now. Yeah? Okay. So, again, it will take some time to digest sometimes, okay? I will assume that, oh, I understood it, everybody understood it. That's why this video is. After the class, sometimes, just go through it. Wherever I'm doing preaching, just skip that part. And only the mathematical part you can revise and then take your notes, okay? So this becomes, the power gets added, 6 plus 6 becomes 12. And this 12 is nothing but 3 times 4. Sidhu, is this relatable?
Huh?
Is this relatable? This 12 is nothing but 3 times 4. That's what we saw happening, correct?
Yeah.
So the 2-3 examples that we saw, we are trying to generalize that as a formula and we are saying, look, okay, x to the power a whole thing to the power b equals x to the power a times b. That's what we saw happening here. This became 3 times 4, 12.
So if you have like 2 to the power of 3, like 1 to the power of like 5 or something,
Yeah?
and then you have another power like 2, it's like 5 times 2.
Yes, sir.
Okay.
Yep, makes sense? Everybody with me? Now, it's my time to take revenge. And parents who are here must be thinking that what kind of teacher is he? My problem is this. I'm myself a father of 2 daughters and my dad jokes come naturally. So you guys will have to deal with those dad jokes, okay? Those are natural. I don't put effort for that. So don't worry about it. Just take it with a pinch of salt. Now, if I say 4 to the power minus 3, what am I talking about? As long as I was talking about 4 to the power 3, I was talking about 4 into 4 into 4. If I'm talking about 4 to the power minus 3, what exactly I'm trying to do here? Kian, what am I trying to do here? Something to the power minus 3.
Negative 4 times negative 4 times negative 4, since the top number is negative.
Wait, what is this?
Okay, let me. Oops. 4 to the power minus 3.
Oh, 4 to the power negative 3.
Negative 3. So take a notebook and sketch your thoughts in the notebook. You'll probably get a different answer. Try that. Yep, of course. And anybody, if you guys are trying to find out a pencil or pen, without even asking me, you can just find it here.
But
Or-
this is to simplify it.
I don't know whether we are trying to simplify it or not. I'm just trying to wrap my head around this one. What exactly is this? If somebody says 2 to the power 4, I know it's very simple. 2 into 2 into 2 into 2. Whether it is 16 or it is 2 to the power 4, I'm very clear about it. I'm struggling with this situation right now. What does a negative power mean? Anahita, any thoughts? Anahita is thinking why the teacher is putting me on the spot. How about Yaganya? Sidhu, Bhavish, any thought?
I think it's because like when you have like a negative power, it makes like you know how when it's a positive power, it makes all the digits positive. Like say like 4 into 3, 4 to the power of 3, right? All the digits are 4 times 4 times 4. I think it's like when it's all those negative when it has a negative power.
I will not say anything. Let everybody think about it. What's happening, Aishu? You were saying something.
If you were to simplify it, then it would be negative 64.
Negative 64.
If you were to simplify
You also think so?
Yeah, I got negative.
You will see my smile very soon. How about you, Svecha?
I'm still
Working on it?
You were there in this class.
I love
Hey,
that.
it's okay. See, I'll tell you. See, these kids would not know what we all have gone through to learn what we have learned by now. I would not disclose that in a public platform. Okay, but We never learn things in one go. It's okay. It's very normal. Yep. Somebody was saying something. Manas.
I got negative 54.
Negative 54, 64. And now, see how sarcastic your teacher is. I'm smiling right now because everybody got the wrong answer.
Negative 12.
Everybody got the wrong answer. Because, I'm sorry? How? I'll prove it. I'm not talking in air. Okay. So, I will not assume anything, okay? Math is not a subject to be assumed. And that is why it stays with us longer if we understand the concept. So I'm talking about 4 to the power minus 3. Okay? Before I do that, let me put something for you guys to recall. We just learned 3 formulas. One of the formula was x to the power a divided by x to the power b equals x to the power a minus b. Okay? This is a formula that we have seen just now, 5 minutes ago. Yeah? Everybody? Or I can also write this as x to the power a minus b equals x to the power a divided by x to the power b. If apple is equal to oranges, oranges are equal to apple as well. Yeah? I just flipped the side, okay? Everybody here. Aishu here, beta. Everybody here, okay? Time to argue with the teacher, okay? Manas, Yaganya, you're not talking at all. Are you going to follow me, beta? Or your network is giving you a hard time? Everybody can hear me and see the board, okay, right? Yeah? Anahita, Manas, Bhavish and Sidhu. Okay. So, I'm just helping you guys recall. This is the formula that we learned 5 minutes ago. And the same formula, A, this equals this, I've written it the reverse order. Yeah? I took a mirror image of that. Now, let's go here. 4 to the power minus 3. Can I not write this as 4 to the power 0 minus 3? Isn't that okay? Minus 2 is 0 minus 2. Minus 3 is 0 minus 3. Minus 20 will be 0 minus 20.
Yeah.
Yeah, that's okay.
Isn't 0?
No. Let your thoughts come through. It's okay. It's fine. This class is meant for making mistakes. I want you guys to make mistakes, but don't restrict your thoughts.
Is it 4? Wait, is that 0 minus 3? Isn't 0 minus 3 negative 3? Because,
That's what I'm not trying to put any intelligent stuff here. I had minus 3. I'm trying to write that minus 3 in a different way. What does minus 3 mean to us? Oh, 0 minus 3. You had nothing and you subtracted 3 from it. That is how you got minus 3. Correct? Everybody with me, right?
So you wrote 0 minus 3 to get negative 3 in a different way?
Yeah, exactly. I'm just representing it differently.
Okay.
Now I'm trying to marry this with what we know as a formula here. So if I have something to the power something minus something, that means this is my power for the numerator and this is my power for the denominator. If you can relate to this. You will have to stare the board with more intensity right now. I have 4 to the power 0 minus 3. And I am relating that with this formula. Something to the power a minus b, that is equal to something to the power a divided by something to the power b. Yeah? I have 0 minus 3. I will write this as 4 to the power 0 divided by 4 to the power 3.
Oh, yeah.
Yeah? Bhavish, Sidhu, Kian, Swechha, making sense to everybody? Anahita? Anahita, are you with me, beta? Am I making sense or not? Don't say yes just because I'm forcing you guys to say yes. Everybody okay?
Yeah.
There's nothing complicated here. Only thing is we have to relate to it. Naita has put oh. I first saw this emoji. I was wondering if I have to explain it one more time. But I hope it's clear to everybody. Everybody? So, let's look at it one more time. Something to the power negative is as good as something to the power 0 minus that number. And this one, if I map it to this formula that we have learned, so if I have something to power something minus something, This is my power for the numerator and this is my power for the denominator. Now 4 to the power 0 is how much? What? What? What is the value of 4 to the power 0? How much it is?
4 to the power 0, 4.
1. It's 1. By 4 to the power 3. So what did we see here in this whole gymnastic that I was doing was, when you have a negative power, you can move this guy from numerator to denominator and the power flips from negative to positive.
Are you pointing at the top of the board or the bottom?
I'm helping you guys look at both the things together.
Okay.
This was the initial situation that we were trying to deal with. Now we have come to this place. What is that we saw with all the transformation was that a negative power translates into a positive power by moving it from numerator to denominator. Moment of silence. Am I making sense? I mean, that's why I'm waiting for you guys to process this first.
Yeah.
Yeah? I don't have to say yes, but okay, this class is meant for making mistakes. I'm okay, you guys making mistakes, that's fine. Or not being convinced in one go. Yeah? When you guys don't make eye contact, I get confused. You okay with it? I'm sure, confident. You can argue with me on this topic tomorrow.
Okay.
Okay, alright. Aisha, okay?
Yeah.
Yeah. Yeah was a little 50-50.
Yeah.
Yeah, okay. Alright. So, net, this is the takeaway. If you have any number to the power negative, it doesn't mean we are trying to do minus 4 to the power 3. This and this are different. Don't relate it that way. That is why you guys were giving me answer like minus 64. There is no minus 64 here. This is, yep. If you guys want me to color it red, I can do that. This is a total stop sign. Yep. Meaning anything to the power, negative power simply means that you have to reverse it from numerator to denominator. Same thing will also apply here. If I say, and this is probably a test of what you guys have seen just now. If I say 1 by 2 to the power minus 2, how much that will be?
1 over 2 to the power.
2 to the power of negative 2 is 1. 0.
Wait, 2?
1 by 2 to the power minus 2.
I'm guessing it's
Math has no chance for guess.
because like
Do it or don't do it.
I got, isn't it positive 4? Because negative and negative equals a positive, right?
Exactly. This is how it travels. If I have a negative power here, I can move it down and the power changes from positive to negative. If I have a negative power here, I can move it upward and this power changes from negative to positive. And if you want to see,
Negative and negative equals a positive, right?
so this is how, again, I will not put any assumption around that. This is equal to 1 by 2 to the power 0 minus 2. This is what I will say. So 1 over this. 1 over 2 to the power 0 divided by 2 to the power 2. That is what it becomes. Now, this thing will flip. So 2 to the power 2 goes to the top, or look at this way. This equals 1 divided by 2 to the power 0 by 2 to the power 2. Correct? And I will convert this to 1 into this flips upside down. 2 to the power 2 divided by 2 to the power 0. 1 into 2 to the power 2. 2 to the power 0 is 1. So this becomes 2 to the power 2. All this is only giving us the clue that if you have a negative power in the denominator, you can move it upward, that will become positive. If you have a negative power here, you can move it downward, it will change to positive. So basically the sign of the exponent changes or reverses when you move it from numerator to denominator or vice versa.
wait, what does that say? It says, can you read that?
One more time.
Where it says 1 times 2 over 2,
This one. 1 into 2. I'm sorry? don't worry about the answer. This is one statement that all my kids hate me for. That is, I don't care about the answer. Because I want you guys to focus on what we are doing. If you are clear about this, you can find your answer by yourself. If you are not clear about what steps you are following here, whether your answer is correct or not, it will not stay with you longer. Yeah? So, answer could go wrong. Perfectly fine. Concepts should not. Approach should not. If you look at whatever I have done in last 45 minutes, there was not even a single problem where I skipped any step. I want it to come like a story. From here to here, here to here, here to here, here to here. These are steps. Tomorrow if I get a wrong answer, let's say it's a multiple choice question where I have 4 options and none of my answers are matching with what I got, at least I would be able to travel backward and figure out where did I go wrong. Yeah? So whenever you are solving any problem, never jump steps. Or no matter whether your writing is good or bad, but don't skip steps, because if you make a mistake, we all do, you would not be able to backtrack it. Was that a great speech or not? The speech, okay. See? Alright. Everybody is playing so far? Now, everybody told me 4 to the power 0 is 1. But why? Oh no, now you do it. Do it on your piece of paper. You prove 10 to the power 0 is 1.
With 4 to the power 0?
Any number to the power 0 is 1, except 0. 0 to the power 0 is 0, everybody knows it.
Yeah.
I want to know any number to the power 0 is 1 and why? That's the question. You guys told me, right? 4 to so any number to the power 0 is 1, right? I'm asking you why. And math always asks for evidence. What is that, beta?
Can you repeat your question? I couldn't hear it.
My question is, okay, let me first ask you a question. How much is 10 to the power 0? 1?
Yeah, 1.
Why?
That's the rule.
No.
Because you're not multiplying it by anything for like it to increase.
See, Manas is already dancing. I can also start swinging. But that will not give me any clue. Okay? So, okay, let me not get you guys stressed out. It's simple. It's based on same exponent rule here. Based on the exponent rule. If I say 5 to the power 0, you are doing the same thing?
What? You said 10 to the power 0.
Oh, 10 to the power 0. Okay, 10 to the power 0. 10 to the power 0 is equal to 1. Okay, that's what we are trying to prove. 10 to the power 0, can I say 10 to the power 0 is same as 10 to the power 1 minus 1? Is that okay?
Yeah.
Or 2 minus 2 or 3 minus 3, whatever you feel like. Yeah?
Yeah.
Now, relate this with the same formula.
Yes, sir.
Yeah? Relate this with this formula now. Something to power something minus something equals something to power something divided by something to power this. So this becomes 10 to the power 1 divided by 10 to the power 1. If you had taken 2 minus 2, it would have been 10 to the power 2 by 10 to the power 2. Yeah.
Is that the second rule on the top?
This is second rule. We have just flipped it. So this rule says x power a divided by x power b equals x power a minus b. I'm reading it from this side. Yeah? Okay. Manas, Bhavish, everybody with me?
Yeah, you will say something?
No, I was just asking whatever I have been doing so far, is it relatable or bothering you guys?
Yeah, I can understand it.
Understand it? If you don't, I am recording myself. You can watch me as many times you can tolerate and then see if that makes sense. Okay? Now, so here, 10 to the power 1 is nothing but 10. 10 to the power 1 is nothing but 10. If I write 5, I'm actually trying saying 5 to the power 1. That's all. So if I have 10 by 10, would I get any answer other than 1? No, right? And you don't have to memorize this. 0 means 1 minus 1, 2 minus 2, 100 minus 100, 500 minus 500. You can choose your number. So I'm not asking you guys to memorize this. Relate it. Yeah? Everybody with me? Now, we have 10 minutes. And in this 10 minutes, I will take you guys for a ride. Is that okay? I want to take you guys for a ride. I have 5 to the power 3 into 3 to the power 9 into 2 to the power minus 7 divided by 5 to the power 8 into 3 to the power minus 2 into 2 to the power minus 7. Minus 8, let's say. This problem I want you guys to solve. This is using 2 of the exponent rules that we have learned and one derivative of dealing with negative exponent also. See how you guys are doing it. It has nothing to do with anything cryptic in nature. As long as you can play with it, you're fine. So I will read.
Like 2 to the power of negative stuff. Like, is it like negative 7 times, like, you know?
I explained that 10 minutes ago.
It's like 1, right?
I will read the question for you guys, whoever cannot see the board clearly. 5 to the power 3 times 3 to the power 9 times 2 to the power minus 7 divided by 5 to the power 8 times 3 to the power minus 2 times 2 to the power minus 8. And though I said that I'll take you guys for a ride, but trust me, this is one of the easiest problems that you can solve if you do it in a very calm and composed way. Don't think that this is a stressful problem. This is actually an easy problem. And I'll show you why I'm saying so. Yes, you do.
Oh, when you're doing exponents, in this type of question, can you cross, like, play tic-tac-toe with...
Why not? Tic-tac-toe is no rule. It's a convenience that we have.
Yeah, but, like, can we play it?
Why not?
Like, in this situation, like, 3 and 3, can we cross it out?
No, you as long as you don't deviate from the basic principles of calculation, you're fine. I will let you guys do whatever you want to do. And more you play with math, more happy I'll be.
Wait, so we can do our own like strategy and like not have to do the regular one like you told us to?
Whatever you want to do, you guys have only 3 minutes for solving this problem.
Okay.
After that, I will start my adventure.
Well, are we finding out the problem of like the equation, the fraction?
Get to a point where you can say this is equal to this by this.
Okay.
I don't want to see repeating numbers in the numerator denominator, if I can say the simplest form. Yeah? Yes, sir. Do it step by step. You are missing the steps. Create a story out of it. And guys, I have stayed away from the camera so that you don't get overwhelmed by seeing my face all the time. Make sure you're making use of those 3 minutes that you have. Yeah, beta.
So I crossed them out after 3 to 2.
No, you cannot do that.
How would you do the exponent?
So here, okay, I'll explain that anyways. Don't worry about it. But here, the thing is, you cross only when you have same thing. 5 to the power 3 is a number, which is 5 to 5 to 5
So they're not the
5.25.
same.
They are not the same, obviously. See, these are 2 exponents. This has a different value, this has a different value. Yeah? So you will, that is why you have to break it down first. Yes, Peter. Hmm?
I first decided to do 5 to the power 2 times 2 to the power 9, but it doesn't.
No. No, you will not. See, when you need 5 to 3 into 3 power 9, These are two different numbers. Okay? You cannot deal with them in this form. You have to either convert them to simplest form, 5 to 5 to 5, 125, and 3 per 9, I don't know how much it is, and then you can multiply them, or you can use one of the exponent rules. See here, you cannot apply the exponent rule because they have different base. You cannot add the power also. Yeah? So, now, here the catch is, you can try finding pairs. Try finding pairs. Try finding pairs and see if you have a way to simplify that. Try it once. I want you guys to struggle with this little bit so that you have your own thoughts around it, and then I'll try solving it. Yeah? Just yeah.
What part is it right on this?
See, first thing is, see, I can give you guys evidence. See how dirty my hands are. So I want you guys to get your hands dirty as well. Meaning, don't look for shortcut in the beginning. Always do it the longest possible way, and then once we do it with comfort, then we will break it down. I will explain it. Okay. 5 power 3 into 5. Let me pick just one example. 5 power 3, and below I have 5 power 8. I can deal with these two guys together. What I can do is move this guy here or move this guy here. Any which way is okay. So if I move this guy above, what will it become? 5 power 3 into 5 to the power minus 8. Now you have two exponents that you are multiplying. It becomes 5 to the power this plus this. 3 plus minus 8, which is as good as 3 minus 8. This becomes 5 to the power 3 minus 8 minus 5. Oh, so see, did you see me being what do you call it? I would not use the term lazy, but I did not assume anything. I was just breaking it down. I was thinking and then doing it. If you go from here to here directly, you would not know how did you get here. So breaking it down is very, very easy. Right? How is the situation right now?
Hard.
Anahita? Yep, yes, better.
I'm about to finish the question.
What is that, better?
I'm about to finish. I just need to make
Okay.
choice.
I will give you guys 30 more seconds and then I'll get going. Yeah.
Kind of got that. Like I simplified as 5 and then I did the rule.
Hmm.
I got that. Is that like.
Mm.
Because I did the thing, because they were both the same thing, I just add jets.
So see here, the thing is, when you have this moving from below to above, minus 8 will become minus 8. So you can add them 3 and minus 8 is minus 5, not 11. Yeah? Here if you see, this minus 2 moves up, becomes plus 2. So this becomes 9 plus 2, 11. Here if you look at it, minus 8 moves up, becomes plus 8. 2 power minus 7 plus 8. I will explain that to you, okay? So, I know where the struggle is. Yes, Anahita, tell me. Anahita, unmute yourself and tell me what is bothering you.
Positive numbers, but I don't understand the negative numbers.
So, now everybody focus on what I'm doing, okay? So don't worry about it, okay? Don't worry about it. See, this is a question probably which will come in SAT exam, okay? Not before that.
You know what?
It might come in SAT exam, not before that. This is a very loaded question for somebody who has just learned exponents. But I'm trying to say that this has nothing to do with any grade. If we know the rules of exponents that we have learned just now, we can apply that as well. We just saw one thing. Any number to the power, any thing to the power negative becomes positive. If I move something from below to above, sign changes from minus to plus, plus to minus. Okay, that. So let's start with that. When you look at this problem, any problem, okay? Now, Anahita, Jaganya, Will, and Kian also. Yeah.
Do you have a bathroom?
Yes, please. Open this door, go straight, and you'll see it. As soon as you enter, you'll see a door right in front of you. Okay? On the right hand side. So, there's one theory that I will tell you guys. This is my magic wand. This is a culture. that I'm trying to build as part of solving math. Any mathematical problem you are trying to solve is based on this. What I mean by that is, have you heard about RAND before? I think you did. Oh, sorry, it's okay. We'll make it a practice. So, who wins the race or who won the race depends on who ran the best. Yeah. Now, what is RAND? Read stands for R stands for read, A stands for analyze, and N stands for Nike. This is a shoe brand which says just do it. What I mean by this is, when you have a problem to solve, read it once, twice, 3 times till you are confident about what is the question asked. Then you start thinking, start putting your thoughts together. Okay, this is how I'm going to approach. These are the formulas I know. This is the concept I'm aware of. So these are the steps I'm going to follow. So you have just made a blueprint. You have not touched the problem to solve. And then you go here. So summary of this is, you have to solve a problem, don't jump onto solving it. Read it enough, come up with your plan, and then you do it. Because in an exam-like scenario where you are constrained for time, if you go take a wrong path and then here you realize after 10 minutes, oh, I took a wrong approach, then those 10 minutes are lost. And that would compromise your chances of getting a little better score that you would have got otherwise. Okay? So that's why I insist on this one. There are kids who have heard this 100 times from me, and I have no shame in saying it 101st time again, because I want this to become a part of your approach itself. Okay? There is a child named Praneeth who starts crying actually if I say this RAM thing. But then my intentions are very clear. I want you guys to get used to it. Okay? Not me, the concept. Okay? Now here's the thing. When I have this question, I'm reading it. Okay, I have this power, negative power. Difficult. Negative power. Then, okay, how do I do it? I'm thinking right now. It might be easy or difficult, we'll figure it out. These are all exponents, we can use exponent rules to solve it. But then first problem that I want to knock off is this negative numbers, negative powers. And that we can do by moving it up or down. Now let's look at it. 5 to the power 3, 3 to the power 9 has a positive exponent, I leave that for now. 2 to the power minus 7, I will move this guy down so that this power becomes positive. So this is also taken care. Now I have 5 to the power 8, this is fine. 3 to the power minus 2, I will move this guy up so that it becomes positive. I have negative again, I will move this guy also up, it becomes positive. Okay? Now look at this. This is an exponent. You can apply the first rule of exponent. This will become 5 to the power 3 into...
Is that a 9? Like above the 3?
Yeah, it's 9.
Okay.
Now, this will become 3 to the power 9 plus 2, 11. These two are combined now. And then 2 to the power 8 divided by 5 to the power 8 into 2 to the power 7. Now look at it. Here you have this one as 3, this one as 8. What you can do is 5 into 5 into 5, this one 8 times, and you can do tic-tac-toe. Same thing with this guy, you can do tic-tac-toe, or you can bring all the 5 together. Let's say here is less power, this is more power. I'll bring this guy down and I'll move this guy up. So it becomes 3 to the power 11, I'll keep that. 2 to the power 8. If I move this guy up, this becomes 2 to the power 7. So 2 to the power 8 times 2 to the power minus 7. This becomes negative by going up. And this guy, when it comes down, it becomes 5 to the power 8 was the original number, and then this comes below 5 to the power minus 3. So this one is standalone, don't worry about it. You are multiplying these two exponents, 2 to the power 8 and 2 to the power minus 7. This will get added, so it becomes 3 to the power 11, and this becomes two exponents with the same base, different power, they will get added. 8 plus minus 7. How much that would be? 8 plus minus 7. 8 minus 7. Divided by this guy. 8 plus minus 3. Same base, you are multiplying the exponents, the powers will get added. 8 and minus 3 will get added. It becomes 5 to the power 8 minus 3. So now this is 3 to the power 11 into 2 to the power 8 minus 7 is 2 to the power 1 divided by 5 to the power 8 minus 3, which is 5 to the power 5. Stressful.
Wait, what's the answer? Can't see.
I will not tell the answer. I have zero respect for answer, okay? No, again, Manas, as I keep saying, I have no respect for answer actually. What I was trying to say here was, when you have a problem like this, your first goal is to simplify things. And first simplification approach is move the negatives to make it positive, and then you'll have a better view of things. Now when you have come to this point, you can leave it here, or you can bring all 5s together, all 2s together, so that you can simplify it using exponent rule. Now whether it comes as this or something else, I would not really be worried about that. Yeah? Because my goal is to explain the concepts to you guys. Whether you're solving 5 problems or 205 problems, I will leave that for you guys, depending on how many problems on a concept makes you more comfortable. So that's a call that you can take. But I would not want to discount on the concept part of it. So as long as everybody is okay with the concept, my job is partly done. Yeah? So no more dad jokes. See you guys day after tomorrow. Okay? Bye-bye.